So welcome again, everyone. On today's session, I want to spend specifically on advanced weather map handling. So I'm sort of giving tribute to the beauty of the backend of StableNet, to the REST API, to the XML structures we are using for almost all over the place, and that can also be used for weather maps. And just as a very quick refresh, so there's another webinar where I had talked earlier about general weather maps and what can be edited there, about the layouting and so on, the new tooltips we have in those weather maps to get more data here for the systems shown. And we had also talked about those statistics. So for each of the nodes, you have a possibility, and for the links as well, you have a possibility to add statistics here. You can define them one by one, which measurements to be used, what data to be shown. You can also provide here the limits for the coloring. And now today, I want to focus on how this can be automated and how you can, for instance, create alarm maps like this one, where you have a weather map which is showing automatically for each of the virtual machines here in my network different parameters in a nicely layout table, giving me color coding for the values if they are okay or in the yellow area or red area. I'm also, like in this case, I'm using the 95% quantiles of the last month, but I can also show here, for instance, I can look at the trend of the last 3 months. So in this case, I created a map automatically where I'm looking at the devices. If the trend has increased by more than a certain predefined threshold, I'm making it red. If it has decreased by more than a certain value, I'm making it in green. And if it's in between the ranges where I say this is not a large difference, like just some megabytes more of RAM or less is not worth like coloring it, then I just leave it as white. So this is also an example. Or another example, which is coming with the feature release 10.1. If you are using capacity metric map, you can actually look into forecasts. So what is happening if my RAM is twice as high, my memory, or if my CPU is increasing? You can also show that here. So today I'm covering precisely this. How can I, in a quick way, starting from a base map, which doesn't contain any statistics, fill this map quickly with a lot of information in table format? So these are for the nodes, and maybe just before getting into the details of how this can be done, I'm also showing some examples for links. So here I'm having a base map with focus on the links between the nodes. And now, for instance, I have one adaptation of this map where I'm having for each of the link, the in discards and out discards from the destination and the source interface. And for instance, here on this link, I can see that the in discards are beyond 1%, so I color them in red. Or I have another map here about the reachability, which is, however, quite boring in our test lab because the reachability is always 100%. But this is also for the links. It's working with the same way with these statistics. And now I want to show you a little bit how this is working. So in order to do that, first of all, we will look here, taking that maybe one of the result maps like this 1128. I have created a special weather map tree here for me, which is a tag tree, which in addition to the name of the weather map directly shows me the object ID. So I don't have to look that up all the time, but I can just directly see it in the tree, which is a simplification for me for programming and working with the API. And now if I'm looking at that map 1128, and for instance, taking this first node here, SNSE, then I can use a REST API client, like for instance, Insomnia. And I'm getting with the weather maps get 1128, I'm actually getting the XML structure of this weather map, and I can see it here. I will dive into this in a moment. Just before diving into this, maybe real quick, if you are not familiar with the REST API yet and you want to get into that, I can recommend you to use our documentation. For instance, the new documentation in a graphical view here in the web. You can look up the REST API documentation, and there you can look up all the specifics. For instance, today I'm working a lot with weather maps. So I'm using weather map add, weather map get, and so on. So much about this. So now let's look a little bit on that weather map, how it's structured. So each weather map in StableNet on the top level of the XML file has some information about a background image, about the time when it has been created. It has an information whether the overall status should be shown or not. The overall status is this little icon on top here. It has information about the zoom factor. So if you are zooming in or out, whether this should be shown. It has the tags obviously listed, so you can see where which tags the weather map had. And now the most interesting part is actually this weather map nodes part. So if I collapse that, you see that almost the whole file is consisting of weather map node content. And more specifically, in that weather map node content, there are a lot of these weather map nodes. And if I'm just maybe picking the first one here, the first weather map node, then I can see, okay, this one has an icon. It has a last update. It has a name. The tooltip URL is typically quite lengthy because you can put a lot of information there as well for intelligent URLs. This is what I showed in the last webinar with the tag filters. The same for the web link, where you can open some sort of a dashboard, for instance, a dynamic dashboard report. And then you have a position in X and Y where the node is located. You can make use of this, or you can just use some organic layout or orthogonal layout or automated layout so that it's not reliant to X and Y. And then you start with an element reference, telling StableNet what is the actual object behind that. And then there's this interesting part, which I'm focusing on today, the statistics part. So each row of the table that you just saw, so here you have a table with several rows, and each of these rows is actually one element here in the statistic. So I actually said we would focus on this SNSE one. So I'm just searching that real quick in my result file. Here it is, down here. So I'm focusing on that upper left node, SNSE. I can see the name. I can see that there's some tooltip URL, some X and Y coordinates. And now I have, in total, I have 5 different statistics, 5 rows in my table. The first one's called power. The second is overall, connection, CPU, and RAM. And if I'm just jumping back here, power, overall, connection, CPU, and RAM. And each of these fields then has a default state, which is typically 0, so green, and it has a range, which is defining from 1 to 1. It's actually green. From 0 to 0, it's 4,000. This is in the case like 0 means that the power is turned off, so it's shown as a major color in red, which is 4,000. And 2 is a suspended state, in this case, which is 500, which is warning. So all these numbers you can look up in the documentation, and you can also play around with using other XML examples and looking it up there. And then you have a reference of the actual measurement, which is providing the value. And now, so this is roughly to give you an understanding of the XML structure. Now, for the sake of time, I'm directly jumping into how I'm actually using this. So for the sake of that, we have prepared a Python script, which is actually filling that weather map with statistics based on a CSV file. I will first show the CSV file because then I think it's more intuitive to work with. So I have here defined a comma-separated value file, and in each line, I have actually defined that for a certain measurement, I want a certain measurement. For instance, I want a power I want the power state. With a certain range, so with the coloring of the last month. Some of the columns I have here for additional settings I'm not actually using, so the script can do more than I use in my example. And it's actually a node on a measurement domain. And what I want to do now is, with my script, I want to find all the nodes on the weather map where I have a measurement that is that contains the string power and has a metric unit state. And in this case, I will add this power to all these nodes. I will add overall to all the nodes. I will add connection. And this is actually the result, is that for all the nodes, I have power, overall, and connection if it's existing. So to get a little bit into the script starts with some imports of code definitions and some functionality for reading in CSV. I think this is no special detail I need to show today. It's just for the people working with Python to see more clearly. By the way, we can make the script available if you are interested. So just contact us. We might also put it to the StableNet user forum. That's actually a plan to do that as well. And then I'm actually creating these statistic objects here. Don't need to show all this functionality. The actual code is happening down here. So I'm connecting to my server that I'm working with today, entering my password. I will actually just run that once. So I'll say run all above selected cells. So now I have run everything before. I'm running the connection to my server, logging in here. And the first thing I'm doing, I'm checking my credentials and getting a list of all the weather maps. So here I can see all my weather maps that I have. And now let's say that I want to use as a base, I want to use my InfoSim data center base map, the 1058 that's already provided. And I want to have, I want to use that CSV file Q95 that I just used. But in order to show you that it's actually live and running, I'm editing this to the 98% quantile or to the maximum value. Let's show the maximum. That's actually even more interesting. It's the highest value. This is a thing of the Jupyter that I need to edit it in this text file mode. Okay, that's it. It's edited. And now I'm actually saying here that this is the maximum of the last month for the webinar. Here we go. I'm reading in the statistic file. So I get some output here, which tells me that I have 10 lines in total in my CSV file. And for instance, here I'm getting the processor total, the maximum value of the last month. I'm naming this CPU total and I'm putting it as a statistic. And then the actual sort of magic is happening here. I'm getting my source weather map, the 1058 that I provided before. I'm iterating through all the nodes and links in the network. And for each of the nodes, for each of the elements there, I'm actually searching that statistic with the helper functions above. And I'm actually adding that statistic. This is happening here in that code. So I'm computing the statistic title and appending the statistic tag to the weather map. And then I'm finally sending a post request weather maps add to actually add the weather map. And now I'm just running this. So it gives me some feedback, what it's actually doing. Still running. As soon as there is a number, it's done. And now if I go back to StableNet, I actually see I have just created my new weather map here of the maximum values for the last month for the webinar. And if I'm actually now taking this as an SE as an example, so I'm just selecting that node. Here we are for the sake speed. So I see that now I have my metrics that fit. I have the maximum, and if I'm, I actually have the maximum, and before I had the quantiles. And these are the ranges that I provided. 0 is a major, 2 is a warning, and 1 is a okay that I mentioned before. So that's the general principle, how this is working. The Python code we will make available. I don't want to over exceed the time here. I want to keep it short, but the idea again is you are taking weather maps as XML. You are extending the statistics based on the REST API by finding the adequate measurements. And that is a way to create those weather maps. Real quick, some other examples that you can do here with the same principle. One thing that I showed in the last webinar really quick is that you can also take a weather map and enhance it with alarms. So you can basically iterate through all the live open alarms using REST again in the network, in StableNet, and add alarm values. So I'm showing this here in an example as well. This data center map here has alarms added. So if I go with a mouse over in the tooltip, I see all the alarms related to that specific device. And I can actually see directly, okay, here there's a problem with the overall status, or here there are problems with some chassis or with some power supply. So this is another thing. I enhanced this directly with the REST API. iterating through all live open alarms and adding statistic objects for the monitors for each of the alarms. Another thing you can do is here we have a script where I'm actually backing up my weather maps to the file system. This is quite straightforward. I'm up here providing a directory, iterating through all my maps. And then for each of the map, I'm actually saving a PNG file of a picture of the map using plot. And I'm saving an XML file of the map using a get command. So that way I get a full folder which has all my weather maps on the system as PNG and XML. And at the end, I'm even adding it to a zip file so I can directly download it and use it for backupping. Another script we have is transferring of weather maps. This is specifically interesting if you are working with different StableNet servers and want to transfer a weather map from one system to another system where you have to take care of the changing references of the elements because object IDs between different systems are typically different. There we have a script where we are showing how you can, for instance, map the devices between two different systems using the device name. So this script is running on one system, looking up the device name, finding it on the second system, and creating a weather map that looks the same but updates the element references. So this is just to show you some of the examples. And last but not least, also one example that I built here for the webinar is it loads for a short moment, is a weather map gallery that you can also create. So in this case, I have, for instance, created a gallery, one weather map which contains thumbnails of all the weather maps which are here in node statistics examples. So I have an overview of all the other weather maps, and I can from there directly, if I look at one of these examples, is actually containing a direct link to the corresponding map, and I can shift click it and will directly jump to that other weather map. So this is more like for playing around, but it can also help you. I can actually show that script real quick. It's really short. You are just iterating here. You are getting the weather map for each of the weather maps that is in the node statistic example folder or having this tag. You are actually adding a new weather map URL, and that way you can build this picture gallery. So yet another example. So to summarize my webinar, as I'm a fast talker and showed a lot of topics today, today, I wanted to show you the backend of the StableNet weather maps, these XML structures, how those weather maps are built, and how REST can be used using the get command, using the add weather map command to actually influence and change these weather maps. You can also modify existing weather maps, so it's not always about adding, but you can modify. And that way, you can really create a lot of additional automation outside outside in the script language you like to really, for instance, create maps like this one or that one with a lot of information. The scripts are available upon request, and I'm very happy to provide them. Thank you very much.